Even the briefest look at a basic mixing desk like this makes you think, well, what does all of this mean? What does all the writing mean? What do all the symbols mean? Well, herewith an A to Z compendium of studio terms and signs and a bit of explanation about how it all works. It's fully indexed in the description box below. You can skip to any part you like. There are also links to other videos that I've made that go more in depth on a particular subject. Let's have a look. A to D, amplitude, analog. I'm going to deal with these three things together because actually they're all connected. Everything you hear on planet Earth is an analog signal. You know, the gun going off, the rustling of the trees, somebody walking down the road speaking. It's all disturbances of the air that are continuously variable in amplitude and, of course, in frequency, which is wavelength. So there's lots of variable things going on. Now, a computer won't know what to do with any of this information unless it's given the information in the correct way. Now, this is what the A to D does. And this is the same as your audio interface, the little box you've got in front of your computer that's got a mic input and a USB on the back. Essentially, what that does is it turns this continuously variable information into numbers, into digital numbers, which are zeros and ones that the computer can then deal with. Then the computer will play back that information through the same device and turn it back into the analog domain. Why does it have to turn it back into analog? Well, it's the only thing we can hear. We don't hear digital information at all. There's no such thing as a digital microphone or a digital speaker. Yes, it may say so on the box, but actually a microphone will always deal with an analog signal first before converting it into digital. So you can get the mics with a USB on the bottom. Essentially, you've got the converter inside the mic. Likewise, same thing happens with the speaker. You have a D to A, and the opposite, digital to analog converter. So it takes digital information and puts it back into a variable voltage that then we can interpret as sound. A is for assign as well. Well, if we've got a mixing desk here, you can have these little switches next to the faders, which allow essentially you to assign or direct your signal to any output or any other place on the mixing desk. So you have these assignment switches, which are also connected with buses, which I'll explain in a later part of this video. A is also for auxiliary. Now, on this mixing desk, we have the equalization section, we'll cover that later, and we have these other things called aux. Sometimes they're also called sends or effects or something like that. Now, what happens is, as the signal comes through the channel, you will ultimately hear it when you raise the fader. But you may want to send the signal elsewhere, for example, a monitor speaker on stage or an effects unit. Now, a monitor signal on stage you can actually assign to one of these auxiliaries here. And you have pre-fade ones really for monitors, which means that if the engineer is tweaking your fader, it's not going to affect the signal level that's coming out of your auxiliary, so you can do your own monitor mix. However, if you've got a reverb, you want the amount of reverb to be proportional to your direct signal level here. So you also have post-fade auxes. This one is labelled effects, actually, and you will find that on smaller mixing desks where you have post-fade. Sometimes there's a switch, as there is on here, where you can switch between pre-fade or post-fade. So we could have two effects buses here, for example. So it's quite flexible. You'll find lots of buttons with pre and post as well. We have balanced and unbalanced signals. What are these then? Well, a microphone is a good example of a balanced signal. You have 3 pins on a standard XLR cable. And what do the 3 pins do? Well, one is going to be ground, and the other 2 are going to be signal wires. And there are 2 of them. Now, what happens when a microphone outputs its signal? One of the pins has a wave that goes up and down, and the other has a down and an up. So you have a signal that does that. The idea of this is that you send 2 completely different opposing signals down one cable, and at the other end, at the mixing desk end, one of those signals is then flipped upside down so that you end up with 2 signals that are doing this. You think, well, what's the point in that? Well, if you have interference on the line, the interference is going to appear on the line in exactly the same polarity across both your cables. The idea being that when you flip one of those, +1 plus minus 1 gives you 0. So you can end up cancelling out the interference, but actually retaining your signal, which is the whole idea of a balanced line. An unbalanced line is only one signal cable. So, for example, you have a guitar. The output of an electric guitar is an unbalanced signal. The disadvantage, of course, being that if you have a long signal chain or long cable, you can get sort of interference along the line. You can end up with something at the other end that doesn't really resemble what happened at the source. Most CD players or keyboards tend to output unbalanced signals. Professional stuff tends to have balanced outs and ins. In the case of a mixing desk, you can get a balanced jack. More about connectors a bit later. So bass and bass cut. Well, bass is essentially the bottom end, the sort of boominess of any sound. And sometimes you don't want this. Bass can be a real problem. Now, if you have a mix, for example, that's got a lot of bass on things that don't need the bass, things like microphones pick up lots and lots of it. So you end up with this cloudy mix. You only want bass on your bass drum and bass guitar or other bass instruments like a double bass or a bass synth or that sort of thing. You may want some bass on your low tom as well, but really nothing else. What's the point of having bass end on a violin? There isn't any. But a microphone, a modern microphone, will pick up lots of boominess and rumble that exists just in the air and in the floor and just general ambience. So when you play back, you have a lot of problems with your bass because lots of mics adding together with lots of bass means that you're wasting a lot of energy with your speaker and your general audio level. It's said that 80% of the energy in a sound wave is below 200 hertz. So essentially bass is where it is. That's the reason why a bass speaker is bigger than a treble one. It's got more air to move. It's got more energy to deal with. Now, a mixing desk, and just returning back to this little Behringer here, has a switch at the top that says low cut. Now, this could be bass cut, it could be low cut, it could be something called HPF, which is high pass filter. It may even be a line, two lines, actually. It's a diagonal and then a straight line. Basically, what that means is that it is cutting frequencies below a certain amount to sort of circumvent this problem. You can do this online, on your computer as well, but very, very often mics also have bass cut. Now, this is just to keep all of this low end under control. It's really important. Sometimes you'll see the words dB per octave or dB/oct after this. Well, that's takes a little bit of explaining, but essentially it says how sharp your bass cutoff is. The less dB figure per octave, it means it just cuts it very gradually. If the dB per octave is something like 24 or that's quite high, then the cutoff will be much, much steeper. You've got to be careful. Some microphones, like the AKG C3000, for example, cut really below about 500 hertz, which is quite a lot of bass cut. So you suddenly think, oh, where's all my level gone? It's actually cutting some of the low mid as well. So just sort of keep an eye on your bass. It's really important. Bright switch. This is usually found on the front of instrument amplifiers, guitar and bass amps. It's essentially a treble boost. Now, this can be also linked to things like presence and the treble control itself, but bright switch very often on a guitar will allow it to cut through the mix a bit more. It just switches the top end or the treble much, much higher. A bus is something that you would find on a mixing desk, a larger mixing desk that maybe has a lot of input channels and then some other faders that allow you to actually group things together. So this is kind of busing and grouping is a similar thing. Now, what happens is a bus has got double S in its terminology, but really we should think of a bus as a single S because actually it's exactly the same thing. If you're this is 50 people that want to go along one road. It's better to have a bus because it's a single thing that you can transport everybody at the same time. That's kind of how it works on a mixer as well. You have 8 inputs, maybe for your drums. You've got kick drum, snare drum, hi-hats, tom, and overheads, for example. So you've got 8 mics on your drum kit. It's pretty hard to control 8 faders at once if you want to vary the level of the drums as a whole. So the idea is that you then send those 8 faders to perhaps two faders, which are the buses 1 and 2, for example. Why do you have two? Well, it's nice to have drums in stereo, but you could do this with vocals. You could have all your backing vocals on one fader, for example. So you're grouping things together. Buses are also used to output signals from a mixing desk to a tape recorder, for example, or a multi-track machine, which might have 8 inputs. So your mixing desk might have 32 channels, but actually you need to be able to send any of those channels to any of your 8 tape tracks, for example. So that's what buses do. They essentially route those signals to wherever you want them to go. A channel is a circuit that you send an audio signal down. It's different to track. Track is a physical thing that you'd have on the tape machine, for example. That's got the heads have got tracks on, but you can sometimes link a channel to a track as well. The little Fostex R8 behind me is an 8-channel, 8-track recorder. So the channels represent the circuitry that's on the recorder. The tracks represent the physical things on the head. On a mixing desk, you can have a channel switch that you can switch on or off. Why would you want to switch a channel off? Well, everything generates noise, little bits of hiss and crackle and pops and all of this stuff, however tiny it might be. So sometimes if you don't need a channel at all, you can just switch it off and leave the fader in the same position. It just cleans things up a bit. Clip and clipping. This is what happens when an analog circuit can no longer cope with the signal that's running through it. You get distortion, which is usually clipping distortion. Now, on a mixing desk like this, you've got a little red light at the bottom of each channel. And basically what that does is, if the level is too high, the light will come on. And there's a clip level on the output as well. So there's lots and lots of places in a mixing desk where the clip circuitry will detect if there's a problem. So usually on a channel, you'll have a sensor on the mic input itself. You'll have a sensor just after the equalization. If you turn the bass up a lot, you can introduce clipping that way, especially if it's a bass instrument, because most of the energy in a sound wave is that bass end. The way to deal with it is to make sure that you get your gain staging sorted out. And we'll cover that in a later part of this demonstration. But clip light usually comes on maybe a couple of dB before clipping actually occurs. So if it flicks on very, very briefly, don't worry about it. It doesn't really matter. Of course, if it's a precious recording, yeah, you don't want to have that clip light on too much, but in live use, it's absolutely fine. The Cloudlifter, this really nifty little box, amplifies signals from very weak microphones. So, for example, some ribbon mics output hardly anything at all, just due to the nature of their physical makeup. So you need to raise the gain of your mic signal before you then go into your audio interface. Sometimes if you've got a cheaper audio interface, something like this is really useful. If you've got a good one with a lot of gain, you may not need one of these. But it's always useful to have one of these around. If you have an old mic, maybe the mic itself is unbalanced, even though it's got an XLR on it, this is the sort of thing you need. It's powered by phantom power, which goes in through its output, but the phantom power doesn't get passed to the output, so it's ideal for things like ribbon mics that don't like phantom power at all. So it's a really useful little box. The compressor, or in some terms, the limiting amplifier, you'll see that on the front of some hardware compressors. This is basically a device that's used to not only restrict the sort of peaks from getting through and creating distortion on your recorder, but it also creates the impression of loudness, because actually what it does is it narrows the dynamic range of a signal. I've got a compressor on this mic at the moment that you're listening to me on, because I want the overall level of my voice to be as loud as the advert that came before this video. So you have the loudest signals and the quietest signals. And essentially what you do is you compress the loudest signals down to a certain level, and then you turn everything up. That's basically what it does. It creates the impression of loudness and means that on a vocal track, for example, you can hear every syllable and every word above the band. It's an essential part in any studio. Sometimes you can use one to record with, where you actually plug everything through the compressor and you set it up so that it's not squashing it too much. You don't want to squeeze all the life out of your recordings. Lots of people just put the compressor on maximum so that it's just this sort of fat sound right in your face, but actually it gets very tiring after a while. So that's the compressor. I've done a link in the box below to some more detailed sort of explanation of some of the controls, like threshold and release and attack times and all of that sort of thing. Control room is used to describe the volume that simply feeds your studio monitors or your headphones. So it doesn't affect things like the level going to your tape recorder or any recording levels. On the mixing desk here, there's just this one control knob here, and all that does is it varies the output of the mixing desk through your main studio monitors. It's simply a method of just keeping everything separate from any recording levels or any levels to tape. The dB scale stands for decibels. Now, in acoustic terms, this could be a plane taking off from an airport being 160 dB, or a rock concert being 120, or leaves rustling in the wind might be 30 dB, for example. Now, in electrical terms or in mixing desk terms, the dB scale is used rather differently. In acoustic terms, 0 dB means complete silence, which basically doesn't exist anywhere. But in electrical terms, 0 dB means something called unity gain, or no change in audio level at all. Now, this can be illustrated by the tone control or the equalization circuit on a mixer. We've got, at the moment, let's take this channel, for example, the treble is in the middle, and it shows a little 0 on the display on the control knob there. That means that there is no change in the treble response of that channel. If I turn it all the way around to the right, I get to plus 15, and then all the way to the left, I get minus 15. So that implies that there is a change to the level passing through for that particular, this is the treble response, for example. Now, it's important to realize that plus 6 dB in an electrical circuit represents a doubling of level, a doubling of volume level. So minus 6 dB is a halving of that. Some people say, no, it's 3 dB, but it's 3 dB in acoustic terms. In electrical terms, it's 6. Now, what we've got here also are little numbers next to your faders, for example. We've got infinity, 60, 40, 30, 25, 20. This is essentially the concept of attenuating or boosting. 0 dB is about 3/4 of the way up. That means that this fader is acting as, it's not boosting or cutting anything. If I bring it down here, it's actually attenuating the signal. It's applying dB cut, which is why the numbers get bigger and bigger until they get to the bottom where it says infinity, and that means essentially the channel is off. And then the other way, I can boost up to 10 dB there. The same is represented on this bar graph, which is showing the overall output of your main mix, and the main mix faders have the same scale on them as well. So if I put these up to 0 dB there, it implies that my level should be 0 dB on the meter. Varies in practice, it depends what's going on with your channels, for example. So the bar graph meter has green LEDs which represent sort of signal being present. Then orange to mean you're actually boosting slightly, and then red means it's too much for the analog circuit to cope with, and you end up with distortion. So we don't want that. So we've got 0 in the middle, and then numbers increasing as they go down, which is attenuation, and numbers being boosted, or numbers going up, which means that you're actually adding volume, or you're boosting the audio signal. Now, as I said just now, it's 6 dB in terms of electrical signal level. Speakers are slightly different. As soon as you start bringing in things like current flow and therefore a resistance across that speaker, it turns into more like a 3 dB boosting or cutting. So, and that goes for acoustic level as well. So there's a bit about the dB scale. The more dB you have with your EQ, if it was plus 20 or minus 20, that implies that the EQ is a bit more powerful. Indeed, on Logic, you can have plus or minus 30 dB, which is massive. But on a mixing desk, 15 dB is perfectly adequate for your needs. If you're having to EQ lots and boost massively or cut massively, the chances are there's something wrong with the source material. So that's an explanation of the dB scale. A de-esser. What does this do? Well, it does exactly what it says. It takes S sounds away, predominantly from the human voice, but also other instruments rich in high frequency content, like hi-hats, for example. Now, what actually happens is it compresses over a very narrow frequency band. So when you say an S sound, it just reduces the level of a particular frequency, and usually you can set that. You can find a de-esser on some more expensive mic preamps, and you can also invariably find it on any digital audio workstation. So you just put the de-esser in front of your vocal and it just calms those S sounds down a bit. This is especially important if you're cutting a record. A vinyl record cannot cope with large amounts of high frequencies, which is what's present in the human voice when you have your S and your T and your ch and all of those sort of other sounds. Indeed, if you record onto a record, if you cut a record without a de-esser, you're going to get a nasty shock on playback because the S sounds are really distorted. They go instead of s, so you get a really distorted, nasty level. And actually it needs to be reined in. You can, on a de-esser, you can usually select the amount of attenuation of a particular sound. And of course, it's going to be different for different people. If you're watching in the UK, Evan Davis, who is a BBC presenter, he has a lot of very, very pure high frequency content. So he's got kind of the opposite to somebody with a lisp, for example, where S sounds are actually almost compressed by themselves. So a de-esser should be used differently for every single person. A hi-hat cymbal may have a particularly annoying frequency, but usually if in that case, you might need to mic it up a bit differently or do a little bit with your EQing before you record. So that's what a de-esser does. It just keeps high frequency detail in check. Delay. Now, why am I describing one studio effect over another? Well, actually, it also manifests itself as a corrective measure, especially with live work or if you're trying to sort out phasing problems on a recording. Very, very short delays can help you there. Now, delay on an effects unit would be something that just reproduces a sound at a given frequency, usually in terms of milliseconds or in terms of beats or eighth notes or whatever. So you can have 1, 1, 1, 1, 1, and you set the feedback for the number of repeats you want and the delay time for your, how separated they're going to be. Now, in terms of on-stage mixing, for example, if you've got a large stage and you've got your speaker system, maybe you've got your subwoofers as well, sometimes you can get a problem where an instrument on stage, but predominantly bass end, actually a bass amp or maybe a guitar and a bass drum, you can actually end up with something called phase cancellations where the bass drum will actually be working against itself, or maybe the bass amp is quite loud on stage, but through the subwoofers, it seems to be that when you switch the subs on, that the bass diminishes. Well, that's actually frequencies or wavelengths working against each other, so you get phase cancellations, and you can apply a delay to your channel in order to try and sort that out, and that will be usually a few milliseconds. It'll be almost not noticeable at all, but when you're adding signals together, it can really make a difference. On a tape recorder, for example, if I was to transfer an old tape onto my computer and one track was very slightly phasing with the other, I could apply a very, very short delay to one track to actually restore that. So that's why delay is actually important to think of in terms of corrective and effects. This is the DI Box, one of your best friends in the studio or on stage. It solves many problems, yet is a very humble little device. What you do is you plug in an unbalanced line level input here, and then it turns it into a microphone signal. So actually, not only is it changing the level, and you think, well, why is it making it much lower and only to be made higher again? Well, it does something much more important than that. It turns an unbalanced signal into a balanced one, which means you can then send it from here many meters without any problems or interference or anything like that. If you've got an acoustic guitar on stage and you plug in straight into a mixing desk but down the end of a 50-foot jack-to-jack lead, by the time that signal gets to the other end, it's not really going to sound very nice at all. It'll be probably very devoid in top end, and it'll have all sorts of interference on it. And if you run it next to anything, you're just going to get all sorts of problems. Whereas if you plug it into this and then it comes out of there, you've basically whisked all of those problems away. Now, there are various buttons on DI boxes. We've got a seconds jack as well. So let's say you're a bass player and you've got your amp on stage, you plug your bass into the input here, and your link or through goes into your bass amp, but you've still got this going to your mixer. So we've got an attenuator as well. If you've got a very, very strong line level, say from I've got a Roland Hammond organ, which is really, really hot output, you could just attenuate the level before it then goes into your mixer. There's two attenuator buttons on this. We've got 0 dB, -20, and then another -20 button, so you can actually have -40 dB. There's a little filter button on this. That tends to just get rid of any excessive high frequencies or lighting sort of system control, any things like that that may get in the way of your signal. On the other side, we've got a ground lift switch. Now, this is really where this thing stands out. If you've got a keyboard that has an earth on its mains plug, the mixing desk at the other side of your hall also has a mains with an earth pin on it, which means that you're going to get earth currents flowing between the earth of the mains and the earth of your audio, and you don't want that. One way to get rid of that earth, and don't try this ever, is to remove the earth of your mains, but it's okay until you die, then it becomes a problem. But instead, you can lift the earth of your audio, and then thereby solving the problem. We've got a phase invert switch on this as well. Now, this could be used if you've got your bass amp on stage and it is interfering with the sub of your PA, for example. If you switch the invert switch, you may get a better result because of the time delay between those two sources, and that may be a problem. So that's another switch that can solve a multitude of ills. So there's quite a lot going on with this. This is a passive DI box. It requires no power at all. In fact, what's inside is a little transformer which turns it into this mic signal. You can get active ones as well. They run either on a 9-volt battery, don't like those, or the phantom power supply of the mixing desk will also supply those boxes. You can get stereo ones, you can get 8-way ones. If you've got lots of keyboards on stage, you can just plug everything into those 8 DI channels and have 8 nice pristine mic level signals coming out. On bigger mixing desks, in addition to having the microphone inputs on each channel and then your bus outputs and your master outputs, each channel may indeed have a direct output. Now, this is great for if you want to multi-track record a gig, or you wish to send a particular channel to somewhere else, somebody's headphones or something. You can use the direct output. Now, this also has a beneficial effect in that you're not having to send the signal through lots and lots of paths. The more audio circuits you send a signal through, the more chance you've got of noise and more distortion and all sorts of other things happening. So direct outputs are usually pre-fader. Sometimes they're pre-EQ as well. Sometimes mixing desks, if you open the mixing desk up, you can actually put a jumper plug so you can set your direct outputs to be whatever you like. It depends on the desk and the model, but direct outputs are really, really useful. And so to the thorny issue of distortion. Now, a guitarist would welcome it because it's part of the electric guitar sound. And actually what's happening when you turn a circuit up too high for the circuit to actually reproduce faithfully, you recreate, or actually you create lots of harmonics that weren't really in the original signal. They're sort of manufactured by the oscillating of the audio circuit. So it's very welcome for a guitarist. If you want really crunchy drum sounds, you could turn the gain controls of your mixing desk up so that you get a real fizzy sort of sound. But generally speaking, you want to avoid distortion at all costs. It's not limited to just clipping distortion where you turn the thing up too much and you get your harmonics. You can have phase distortion, or you can have quantization distortion where the A to D in your system isn't working properly. Or indeed you can have modulation distortion. You can have things like speakers that color the sound. You know, if you're not getting a perfect frequency response, that's a form of distortion. Essentially, it means that you're getting out not really what you put in. The same applies to my 1/4-inch tape machine. Although it sounds lovely, of course it's going to distort the sound very slightly. There's going to be all sorts of things going on in there that mean the sound you get out isn't exactly what you put in. That's kind of what distortion is. EQ stands for equalization, and it's essentially correcting or adjusting any part of the audio spectrum from 20 Hz all the way up to 20 kilohertz. Now you have 20 Hz, which is very low bass, and 20 kilohertz, which is very, very high treble. It's sort of breathiness, but everything else in between can be adjusted. Now, on a mixing desk like this, for example, we've got a 3-band EQ. 3-band, what does that mean? Well, we got bass and treble, which are either end, and then in the middle we have something called a swept mid or parametric. Now what that means is that you can select any of the mid frequencies and then boost or cut that particular frequency. And on a desk like this, or my other analog desk here, it's designed in such a way to be sort of a jack of all trades and musical. However, when you move to a digital audio workstation, you can do a lot more. You can sort of have a very narrow band that you boost or cut. So that's parametric equalization, and it includes the Q factor, which I shall describe a bit later on because it's the only thing I've got that starts with the letter Q. Now, we also have shelving filters. You find these on hi-fi amps, for example, which is bass and treble. So bass on a hi-fi amp will boost everything from about 120 Hertz downwards. So you end up with something called a shelf filter. And then at the other end for your treble at sort of 10 kilohertz or so. We also have high pass and low pass filtering. So that means that you've got the straight frequency band, and then at the top it slopes off. Now that's called a low pass filter. So it allows all the low frequencies to pass and cuts the high frequencies. And then you have a high pass filter, which is the other way. And that's including the bass cut switch on the mixing desk that I described earlier. Now we have the slope, the steepness of the slope. That's usually expressed in decibels per octave. Now, an octave is a doubling of frequency. So let's say you've got 6 dB per octave cut. That means at 4 kilohertz, when you cut your treble, by the time you get to 8 kilohertz, you're down 6 dB. Now, that's not a particularly sharp cutoff. You can get anything up to 24 or even higher. And of course, on the computer, you can do a bit more than you can on an analog desk. Now, having all of this control on your digital audio workstation isn't necessarily better, because you can very easily color the sound and create something that's a little bit clinical and a little bit false. But you can use equalization as simply a corrective tool. That's really what it's designed to do. Now, we also have a graphic equalizer. Now, what this is usually a piece of hardware where you have 31 bands. That's a professional graphic equalizer. You can have fewer than that if you've got a hi-fi graphic. That might be 10 band, for example. So 31 band, you go all the way from 20 Hertz to 20 kilohertz. You have 20, 25, 32, 40, 50, and then essentially all the way up. You have 3 bands per octave. Sometimes it's called third octave equalization. And that is basically how EQ works. Don't forget your mid-range in the mix. Everyone goes, oh yeah, loads of bass, lovely, and loads of breathiness, how lovely. But then the mid is a bit sort of neglected sometimes. So make sure, don't forget your mids. The fader on a mixing desk is your output volume control. So when you're mixing, you've got all of these controls, and they are simply volume controls. However, they behave in a sort of a bit of a weird way in that unity gain, 0 dB, is about there. Now, round the 0 dB line, you have much, much finer control over the volume level than you do anywhere else on the travel of the fader. So if you're down here somewhere and you're tinkering with the volume there, it's going to make more of a difference to your volume. So ideally, you should be having the fader at 0. If that means you need to turn the gain down a bit on the input channel, then you can do that. You can switch that, or you can turn the gain down slightly in order that you can have fine control. Of course, you've got to gain match everything, and that's something that we're going to talk about in a second. Feedback is the bane of any audio engineer's life at a live venue. You don't want any of that, because actually not only does it sound pretty nasty and make you go deaf if you're exposed to it for long enough, but it can cook speakers, amplifiers. It can do a lot of damage. Now, basically what it is a microphone on stage will be picking up its own output through the front of the house, front of house PA. As long as it doesn't grow in level, that's fine. But as soon as you get a loop going where the microphone is amplifying its own voice and then it gets louder and louder and louder. That's where you get feedback frequencies. It usually manifests itself as a single note, but you do get, if you are ringing out a system, so you are setting up a PA system and pushing the output as high as it will go, usually you're going to get a mid-range frequency and then a top and then a bottom. So that's referring back to the graphic equalizer. Sometimes you can correct for that, and some digital mixing desks will have this built in. They'll find the frequency and eliminate it. That's very useful, but yeah, you really need to make sure that your speakers are positioned behind the mics and that any monitoring systems aren't pointing straight at the mic. Feedback is a major problem and it's very easily avoided, but you just need to take care with it. The frequency response of a system is essentially how it will respond to every audio frequency between 20 Hz and 20 kHz. And the ideal thing is to have something that will respond to all frequencies. However, on the side of a packet, if it says frequency response 20 to 20 kHz, 20 Hz to 20,000 Hz, it doesn't really mean anything because it might be good at those two frequencies, but in between it could be doing this. So usually you'll have an extra specification that says plus or minus a certain amount of decibels. So my old analog mixing desk here, for example, will respond from 20 Hz to 20 kHz from any input to any output, plus or minus 0.5 dB. That's pretty impressive. But my audio interface here will do even better than that. It's 20 Hz to 20 kHz, plus or minus 0.2 dB. So it's really very, very accurate. You will find that microphones have sort of, hills and dales in their frequency response, as do speakers. So there's always going to be some coloration of the sound somewhere along the way, but ultimately your ears are the ultimate judge. So it doesn't really matter if you are hearing something that's slightly deficient. If it's slightly deficient in some way, you can correct it with some EQ, but things like old cassette decks or some really old cheap microphones will have such a poor frequency response that you can't really use them in a professional context. Gain or trim or sensitivity, this is the input control of a mixing desk and an audio interface to a degree. Now, when you first plug in a mic to a channel, the first control you see is your sensitivity, and it's actually called trim on this desk, but called gain on something else. So whatever your input control is at the top. Now this is an amplifier that turns a microphone signal from a few tens of millivolts into maybe a volt or two. So it's amplifying to, 100 times the voltage. So it's it's very easy to get this a bit wrong. If you have the trim too low, the sensitivity too low, and then you push up the volume, you're going to be pushing up noise. It's not such a huge problem on the very best stuff, but if you've got a mixing desk that's maybe a few years old, you've got to make sure that you set that control right so that the audio level from your mic is amplified in such a way that it can be handled by the EQ and it sends the correct levels to your reverbs or your monitor speakers or whatever. So you usually have a button with it, which I'm going to describe in a minute, called PFL, which allows you to set that input gain. As an addendum to that previous thing about gain, there is also gain staging or gain matching. Now this is basically how you make sure that each bit of kit in your audio chain is receiving its correct level. So you can have input and output gains on lots of things. A mixing desk can have your trim, then your fader can be up, and then your group might be up to the top, but your audio recorder or your computer might be registering overload. So you've got to work out where the gain problem is. It could be that the trim is too high, or you could just bring down your channel fader a bit, or the bus fader. You've just got to make sure that you've got a good healthy level right at the start. If you've got a very, very low level and you're having to boost, you're boosting lots of noise that's in your audio chain. So you need to make sure that you've got a good healthy level first. If indeed that healthy level sort of adds to something that's too loud, you can take a little bit off each one just to equalize it along the way. Sometimes you won't need to do that if you've set up your machine. If you've got an old hard disk recorder or a tape recorder, you can set it so that the bus output is right at the top, and it gives you your nice healthy level. And there's all sorts of adjustments that can be made on old analog bits of gear. Of course, with an audio interface, you've got to make sure that you are not overloading that input, because there are no such controls for that, and it goes onto the computer and it's too loud, and you get digital distortion, which you don't want because it doesn't sound very nice. Group. This is another name really for a bus output. You can group instruments together. I mentioned the drums earlier, where you've got 8 faders and you can send them to groups so that you've got one fader that controls the level, or 2 faders if it's stereo, that control the level of your overall output. So group and bus are pretty much the same thing. Electric guitars, they have a sound all of their own, and actually an electric guitar is nothing without the amplifier to go with it. Now, this is not as silly as it sounds. A harpsichord needs a wood-panelled room. That's the amplifier for that. Or a violin, the amplifier is the room that you're playing it in. Whereas a guitar, you need an electrical amplification to make it work. Now, a guitar has a jack plug, so you could theoretically plug a guitar straight into a mixing desk. But this is where you get a bit of an issue, because you are dealing with an electromagnetic pickup that has no amplification of its own. You get this problem with impedance matching. And actually what happens in practice is that you get much, much darker sound. All the top end of the guitar is sort of killed by the fact that the input stage of your mixing desk is actually trying to draw current from the pickup. And of course, the pickup has no current to give. So you're going to end up with a voltage drop, you're going to end up with top end deficiency, all of that sort of thing. So if you do use an electric guitar with a mixing desk, on those sort of rare occasions, you would go into a DI box, which is actually impedance matching to your mixing desk. Now, I showed you the DI box earlier. Now, with a guitar amp, basically, if you mic it up, make sure that you put the mic in the correct place. Now, a speaker, the middle of the speaker, if you point the mic at the middle, you get all the top end, all the sort of top rich harmonic content of the guitar. If you point it to the side, you get a much darker sound because there are fewer harmonics at the edge of that speaker. They're all in the middle. So experiment with that. And be careful with it as well. You also need to make sure that you've got the correct microphone. You don't want to use something that can't handle the output level of a guitar, but also using a mic that's slightly further away from the amplifier in addition to the one that's close. It means that you're recording the box as well. Headroom. What does this mean? Well, it's basically the highest level you can have before distortion occurs, and you've always got to be aware of where headroom is, and ideally use most of the dynamic range of the circuit that you're passing your audio signal through. So if you've got a headroom of, I don't know, 10 dB above zero, don't be afraid to go into it. Don't use tiny bit of it, because actually noise is kind of here. And if your signal is kind of here, and then you amplify that, you're going to be amplifying the noise with it. Now, noise can take many different forms, and I'll talk about that in a second, but headroom is essentially the highest level that you can have without distortion. On a computer, it's 0 dB. You can't go above 0. Everything on a computer recording level is from 0 down to minus whatever. Minus lots. So the headroom, if you're recording a vocal or something, aim for a peak of maybe -6, for example, or -5 dB, so that you've just got a little bit of room left, just in case there are little peaks that might send it into distortion. On the front of an instrument amplifier or on an audio interface, there will be something called a high Z input, or it might be just labelled with a picture of a guitar. Now, I talked about this just now with the electric guitar. High Z means high impedance. High impedance means that it's not going to draw lots of current from the guitar pickup, because of course there isn't any. So when you plug into a guitar input, usually it's a little bit more sensitive, and it won't draw all those top frequencies from the guitar. And you can find these on keyboard amps as well. If you've got a keyboard with a line level, there might be a high impedance input for a guitar or something else that has a passive pickup. Impedance. What does this mean? Well, it means the resistance that is presented to another piece of kit. So if you've got a high impedance input, that means there's a very high resistance input, which means you're not drawing lots of current from your pickup. I talked about that just now with guitars. On the other hand, the output impedance of an amplifier should be virtually nothing. because it's driving a pair of speakers, and you need to deliver as much current as you possibly can to those speakers without a barrier in the way. Generally speaking, inputs should be of higher impedance, outputs should be of lower impedance. Now, this isn't generally an issue when you connect pieces of studio equipment up, because it's all been kind of sorted out. But you need to take care with things like guitars or older microphones that have a jack on, for example. We don't like those. Or something where you definitely get a mismatch in level. If you connect up a mixing desk straight into a pair of speakers, for example, with no amplifier, of course there's not going to be enough current on the output of the mixing desk to run that pair of speakers. You need an amplifier in the way, and that's kind of a way of matching a mixing desk to a pair of speakers. You have an amplifier in the middle that turns a high impedance into a low one. So I've talked about this a little bit with guitar speakers as well, and you can see the link to that video on my channel. Analog mixing desks come in two main sort of different configurations. There's one called an inline console and one called a split. Now, inline means that you have your channels, but you also have your returns from your recorder on the same sort of channel strip. Or you can have a split console, which has got your inputs on one side and your tape returns on the other. The disadvantage of that, of course, is it's going to be twice as big. But the advantage of an inline one is that you can see everything. You can see your tape returns, and you can sometimes swap those as well, so that when you're mixing, you can swap the tape to your faders, and then any inputs or reverbs can go on your little monitor controls. And that's the difference between those two configurations. This one here, there's nothing in line about this. You've just got one thing per channel. There's no sort of extra things. On a lot of mixing desks and a lot of guitar amps, a lot of bits of audio kit, you have something called an insert. Now, this could be a single jack plug where you plug something in and it breaks the signal chain so that you can send it to a reverb or a compressor and then bring it back. Sometimes these jacks, there are actually two of them, and they're called send and return. And when there's nothing plugged in, the signal just passes through them. The disadvantage of this, of course, is if the jack sockets get dusty over time, you can end up with sort of signals being broken. And actually, the mixing desk I've got here, I've soldered across them because I don't really use them. Everything is built into the desk, or I have a preamp and a compressor that I can go straight into my audio interface with. But on a guitar amp, you have a send and return jack. Usually the signal is broken when you plug something into the return, which means you could use the send as a sort of line output. But you've got to be a little bit careful with that, because sometimes you're sending a guitar signal that hasn't been amplified properly. So the guitar amp, you won't hear the proper sound of your guitar. But usually if you have some effects in line, maybe a compressor or reverb or anything, you can plug these into the effects loop, which is another name for it. So you've got insert, send and return, and effects loop, sort of out and back in. The jack plug. It's the most familiar connector to, well, guitarists, keyboard players, anybody really. You can even have it on a pair of headphones. Usually they are 1/4 inch, which are 6.35 millimeters. They've been around for over 100 years, so there must be a lot right with them. You do get different types. You can get the tiny little 3.5 millimeter jacks, which are sort of their consumer level really. That's for smaller pairs of headphones. With jacks, you can have either a single ring round or two rings. Two rings means either stereo or balanced. A single ring means mono or unbalanced. So you've got to know the difference between those two when you're interconnecting a mixer to an audio interface. Usually, line inputs of a mixer, which are on jack plugs, will be balanced, as they will be on an audio interface. So take advantage of that and make sure that you use jack cables that go between the two things that have the two rings on rather than just the one. Now, of course, if you're sending stuff short distance, it doesn't really matter. So that's the jack plug. A kill switch. Now, sometimes this is on a guitar where you just switch the guitar off, so you just want to put it on the stand while you take your break. Or more commonly, it's found on DJ mixers, where you can actually essentially notch out the bass or the middle or the treble to actually a huge degree. Sometimes it's as much as minus 30 or minus 40 dB down. So DJs will use this if they just want to cut the kick drum, or they want to filter out the top end, or bring something else in. It's very useful to have a DJ mixer in your setup, because actually it's the only analog thing that exists where you can do that sort of draconian EQing, that sort of cutting of those bands, and actually really useful sometimes. Line level. This is different to mic level, and different to guitar level, and different to speaker level. Line level essentially is what happens when you connect two bits of kit together, like a mixing desk and the input of an amplifier, or a mixing desk into a reverb unit, or whatever it happens to be. Usually you'd have line level on either a jack. If it's a mono or unbalanced jack, the chances are you'll be operating at minus 10 dB, which is a sort of a consumer level. And if you're on a stereo jack or balanced or an XLR, the chances are you'll be working at plus 4. Now, some bits of kit, older bits of kit, will actually allow you to switch between those two things according to your what desk you've got or what other processing you've got. So actually that's a kind of gain matching between professional level and consumer level. So line level has two distinct types, two distinct operating levels. Mains hum. This is the enemy of every musician, every recording engineer, and sometimes if you've got it between a keyboard and an amplifier or a mixing desk, you can use your DI box with the ground lift switch. However, we've got to be careful, because lots of this stuff, lots of electronic stuff has mains transformers in it, and if you've got something that's a little bit cheap, or one of these sort of little low voltage power supplies running next to a mic cable or a guitar cable, you're going to get some mains hum. Now, this is going to add up if you don't sort those problems out. If you've got a 24-track recording, for example, and you've got mains hum on every track, it's going to add up, and it's really hard to get rid of, because if you're in the UK and Europe, for example, where it's 50 hertz, you are going to try and filter out that 50 hertz with an equalizer. And actually what you're doing is you're kind of wrecking the deep bass end. In America, obviously 60 hertz, you've got the similar sort of problem. So you've got to try and actually address where that mains hum is coming from. Some mixing desks, the better desks, have got a separate mains supply which can live far away from the actual console itself, which sort of diminishes the effect of mains hum, but it's always going to be there. It's always in the ether. When you touch the end of a jack plug, you can hear mains hum coming out of the amplifier, because you've got electromagnetic radiation from your electricity supply, which is amplified by you, if you're touching the jack with your finger, or by any other audio circuit. Master. This is the output of your mixing desk, or the output of anything, where you've got the main, it's called main mix on here. I mean, you can, sometimes it's called mix, or it's basically the fader on the right hand side that controls the overall output. Now, generally speaking, on a mixing desk, you will have the top level being 0. You won't really be boosting anything. On actual channels, you might have a boost of 10 dB, but the master, generally speaking, will not have anything above 0. So you'd leave your master at the top. In the old days where you were mixing and onto a tape, you would bring your master fader down to create a fade. Of course, nowadays on digital audio workstations, you can do that with automation. But your master fader essentially controls the overall output. Mastering. This is very commonly misunderstood. Lots of people think that mastering involves just bringing your tunes up to the loudest possible level, but actually there's a lot more to it than this. Essentially, what you do is you give your mix that you've made in your studio to your mastering engineer, and then they do some processing, very fine control EQing, fine compression, and they also have an idea of where your tunes sit in the marketplace. So actually, there's much more going on than just putting all the faders to the top and making it really loud. You don't want to do this because you don't want to suck all the dynamics out of your record. When you give your mix to a mastering engineer, ideally you should be leaving some headroom, maybe 4 or 5 dB below full scale or below 0 dB, so that the mastering engineer has got something to work with, has got things that they can boost or indeed cut if there's a deficiency. If there's a sort of a honky frequency, for example, you might need to actually cut things. But generally speaking, mastering engineers have years of experience of listening to their sort of preferred music and keeping a really close eye on the marketplace and how records actually sound. When you send something to a mastering facility and they send you back a WAV, be a little bit wary of what they're doing. The ideal thing is to save up some dosh and go to a mastering facility and say, I want this to be, to sound like such and such, or to, But generally speaking, the mastering engineer will know what you want and will give you the results that you need. You can do mastering at home. I do some on my tunes. I just bring the level up and do some multi-band compression, that sort of thing. You can get some plugins on the digital audio workstation which will actually give you it'll say, I don't know, indie or R&B. But be wary, because it depends entirely on the source material. Mic level. This is the opposite to line level. It's tiny, it's a few millivolts, it's absolutely minute. But as I said before, with the balanced XLR, you have a wave that does this and a wave that does this. And then one is reversed at the opposite end. You would have thought that mic level would just be susceptible to all sorts of interference, but not down a balanced line. You can send a mic signal many sort of hundreds of meters with very, very little degradation, which is quite amazing given that the mic is producing virtually nothing at all. Different mics have different output levels. You get high output mics like a Shure SM58 or something if you're screaming into one of those. A ribbon mic, conversely, has a very low output level. So you need something like the Cloudlifter, this amplifier, to put in the way to raise that mic level up. But there are lots and lots of different mic levels, which is why you get your trim control or your input gain on a mixing desk that has a wide range of capabilities. So mic level isn't really standardized like line level is at -10 or +4. It's very much sort of up to that input level control to make that mic level work with your analog processing. Microphones pick up sound according to their polar pickup pattern. You can have things like cardioid, which is heart-shaped cardio, hypercardioid, which is even more a sort of a fine shape. You have omni, which picks up sound all the way round, and you've got figure of 8, which picks up sound behind and in front of the microphone and rejects sound to the side. Indeed, on the 414 here, I can actually choose between 5 different pickup patterns. There's a sort of, there's a cardioid that's a little bit more omni, for example, and you can combine those. So there's masses you can do. Lots of mics only have one pickup pattern, so the C3000 by AKG, for example, is cardioid only. The Shure SM58 is cardioid. The C1000 is cardioid, but you can have a little piece of plastic that you can put over the top of it to make it hypercardioid. So you've got to know what your microphone is picking up. Now, this makes a massive difference when you're dealing with stereo miking. So there are a few different pickup patterns, a few different stereo miking configurations, which basically just determine the sort of stereo that you're going to have. You can have 2 cardioid mics that are in an XY pattern. You can have 2 mics that sort of 3 foot apart, which are omni, and that's called the AB pickup pattern. You can have a Blumlein pair, which is 2 figure of 8 mics sort of off axis towards each other. You can have the mid-side stereo method. There are many, many different ways of using 2 mics in a stereo configuration. Very often it's a good idea to just read up on these, because actually the science, the maths, the acoustics of these different things do take a little bit of understanding. But as ever, your ears are the ultimate judge. There are a few different types of microphone as well. You've got a condenser mic, which is what I'm speaking to you at the moment, sometimes called a capacitor mic. Now, these need phantom power, plus 48 volts to work. Indeed, there are some mics that will work with a lesser voltage. Say you're out in the field or something and you can't muster 48 volts from your battery. So you can also have a dynamic mic. Now, that's a Shure SM58 is dynamic. It's or sometimes called a moving coil mic. It's basically a speaker in reverse. You've got a tiny little speaker, and the disturbances of sound against that diaphragm are what and moves inside a coil and generates a current that way. You also have ribbon microphones. I've got a Coles 4038, which is a ribbon mic, very, very low output level, but really warm sounding mic. So you've got all of these different mic types. So a condenser mic will, generally speaking, pick up a lot of frequencies from very low bass to very, very high treble. The ribbon mic might fall off slightly at the top end, and the dynamic mics generally have a sort of cut off at the top as well. Some mics are designed to have actually a presence boost. There's one on the AKG C1000. The Shure SM58, the eponymous vocal mic, has a lift to actually aid human speech, so it really is tailored towards that sort of towards vocals. Other mics, they have frequency response graphs that do vary a bit, and also the axis, whether you're off axis on the mic. If you're directly in front of it, the frequency range is generally going to be better than if you're offside. This could play into as an advantage if you're doing lots of strings or backing vocals. Let's say you're doing 3 of each part, you could actually record 1 on axis and then the other 2 off axis at varying differences. Not only do you get a different sound, but you're not inviting phase problems, which is coming up in a second. Middle or mid-range. What is this? Well, it's basically everything that's in the middle of your frequency band. So you've got bass one side and you've got treble, and then you've got mid, which could be divided into low mid or high mid. It depends on the mixing desk. This one here has 2 types of channel. On the main mic channels here, we've got a middle frequency that can be varied in terms of it's like a parametric EQ. On the stereo inputs here, we've actually got 2 mid-range controls. We've got low mid and a high mid. So it does afford you a little bit more control over your stereo channels there. But mid-range is something that should never be neglected. Everyone goes on about how tight the bass is and concentrating on the breathiness of the top end. But in the middle, there's lots of stuff going on. There's guitars, there's vocals, snare drum, there's all sorts of stuff which can be sort of left out of the mix if you don't watch your mid-range. Now, the MIDI or the DIN connector. Now, in the 70s, 60s and 70s, hi-fi used to use this 5-pin DIN connector to connect up a radio to an amplifier or a tape machine or whatever. And actually, the MIDI protocol used this connector because it existed and it was dead easy to use. But they are a little bit problematic if you use a MIDI cable. Sometimes, actually, there's only 3 cables wired on a MIDI cable as well, whereas a DIN has 5 wires. So if you use a MIDI cable on an old bit of hi-fi, it's not going to work. Now, DIN connectors are susceptible to having their pins bent, but they're still being used on the back of a brand new audio interface. There's always going to be a MIDI in and out. The MIDI protocol itself dates from the early 1980s. That's how good it is. But don't use it for anything else. For audio, it's not very good at all. Mixing. It's a massive area, and it's also very much down to personal taste, about music style, all sorts of things. However, it's worth grouping the mix and mono and stereo things together, because actually mixing for mono is pretty hard. Mixing for stereo also has its disadvantages. You can end up with phase problems between left and right, but mixing for mono, you've got to be really careful with your frequencies, where things sit in your audio spectrum, because you can't place stuff in a stereo image in mono. It's just one track, one thing coming out at you. So you've got to have layers of loudness. Not only that, you've got to have your frequencies in place. So when you hear a mono mix that's been really nicely done, actually there's quite a lot of work in there. Now, of course, mono, you're very unlikely to come up with any phasing problems because you've just got one channel. Of course, on a tape machine, you can have problems with the head, which means that you end up with azimuth problems with the head angle with respect to the tape. But, I mean, that's kind of old hat now, but, you know, it's worth reading up on. So mixing for stereo, as I said, you can end up with phase problems if you've got a pair of drum overheads, for example, where the mics are actually working against each other, and that will cloud the entire mix. So it's really, really a bit of a can of worms, the whole mixing thing. Monitoring. Well, there's quite a lot of different types. You've got the mixing desk sending your pre-fade aux to your stage monitors, or you've got your pair of monitors in your studio, or a pair of speakers in your studio. Now, Monitor speakers are obviously very important. They will influence every single thing you do. Every EQ decision, any mixing decision, everything comes from your monitors. So it's important that you get a nice pair of monitors that aren't too coloured. That is not sort of hi-fi. You don't want to use a pair of hi-fi speakers really, because they will be deficient in all sorts of frequencies. So the best monitors that you can buy, do that, and it means that you've got more, it's more likely that you'll be able to hear a mix really efficiently. Now, some people used to go into a studio with, you know, a record or a tape or something of an album that they knew really well in order to listen to the monitors and decide kind of their frequency balance. It used to be Donald Fagen's Night Fly. In fact, I still know quite a few people who have that record and just stick it on in the studio just to listen to those monitors. Monitors are not meant to be flattering, ultra flattering to your music. The NS10s from Yamaha are actually some of the least flattering speakers in existence, and many people don't like them because it's hard to make anything sound good on them. But if you do make something sound good on them, they're going to sound, the mix is going to sound really good on other things. Room treatment, that's going to help. And of course, some modern studio monitors come with a microphone where you can actually play noise out of the speakers at all frequencies. You play white noise out of the speakers, and the microphone picks up a sort of frequency response graph of what's going on in your room and then makes corrections accordingly. So there's all sorts of things, but as I said before, your ears are the ultimate judge. Noise is the enemy of everybody involved in music. You don't want any hum, you don't want any hiss, you don't want any pops, crackles, anything like that. Every circuit generates noise. Every single component, a resistor, has an equivalent noise output. You think, well, it's just a passive component, but it still has noise. And so the idea is that you keep the noise or the noise floor down to the minimum level. Now that goes with the sort of headroom, making sure that you make maximum use of the input stage of your mixer, for example, because everything else is going to be dependent on that. Noise is inherent in everything. As I said, it's even more inherent on a tape recorder, for example, so it's important you get your recording level right. It doesn't matter so much these days with decent audio equipment, decent audio interfaces. You can record at quite a low level and actually not really have any noise at all. Some people like noise. I like record noise, record surface noise and crackle. It just connects with the music a bit better sometimes. Now, I'm not a record purist, but actually noise is just something that you've just got to be aware of, and you have to be able to, well, basically say whether you can tolerate it or not. Of course, for professional things, recording sessions and working for film or whatever, you've essentially got to have the cleanest possible level. Outboard. This is a term that's given to anything that you have outside your mixing desk, like a reverb unit or a delay, or indeed things like compressors. It's essentially all of the stuff that you use around your mixing desk to enhance your sound. So outboard could include things like your I've got a sampler in the rack there. I've got some MIDI sound modules. They count as outboard, and they usually sit in a rack that's got a 19-inch fixing. So you can have things like an outboard would be, an equalizer. I've got an equalizer up there. I've got all sorts of bits and pieces that I can connect to the mixer to further change the sound. Lots of people have sort of diverse collection of outboard gear based on their own sort of personal experience or indeed what's in another studio. But you should always use stuff that you like, because actually it keeps things very unique. It's very easy with a computer, the digital audio workstation, to use plugins or use the presets. Whereas if you've got a little bit of outboard gear, it can really personalize your sound. Overdubbing. This is the process by which you record another track over something else that you've just done, or rather next to something else. You don't record over a track, but if you've got track one is your guitar, you can overdub on track two another guitar, you can overdub your vocals, you can overdub this, that and the other. Now, it's not always as easy as it sounds. You've got to be very mindful of things like tempo, count-ins, cueing, that sort of thing. So if you do overdubbing, really, the most accurate way to do it, if you're working on your own, is to work to a click first. That means that any overdubbing, you can listen to the instrument, but you've still got a notion of the tempo. The pan control on a mixing desk simply decides whether the signal on that particular channel is going to go to the left or the right or anywhere in between. So on this mixing desk, we've got a pan control here where you can decide left or right or in the middle. Usually you'll have a little center notch on there or detent on the control knob which says yes, that's going to be in the middle. Where you have a stereo channel, this turns into something called balance, which is like an audio amplifier in your house, or a hi-fi amplifier where you can decide between left and right speakers. So in the case of a stereo input, if you've got something that's slightly heavier on the left hand side, you can turn the balance control to the right. Now the difference between pan and balance is that balance deals with two signals and panning just deals with the one. Sometimes if you've got your groups, if you're sending to a tape recorder, the pan control also doubles with a sort of routing button. So if you've got your routing button 1 and 2, your signal will go to bus 1 or 2 depending on the position of your pan control. PFL. Sometimes you see on the desk there's a little button called PFL. What does that mean? Well, it's called pre-fade listen. Usually it's in conjunction with the solo button. They tend to be one and the same. Now when you press PFL, essentially one of your mixing desk will go into monitor mode and it'll tell you using its meter what is coming in to the particular channel. So it means pre-fade listen. It's basically a way of lining up your channel using the gain control, so you can see what's coming in. You can just use the peak light. You can just bring something in until the peak light comes on and then back it off slightly. But PFL means that your meter gives you a much more accurate indication of what's coming in. There's also something called AFL, after fade listen, which essentially does everything else after the fader. So for example, on an aux send, if you're sending to a reverb, there's usually a button next to it marked AFL so that you can see what is leaving the mixing desk. Phantom power, or sometimes labelled plus 48 volts, is something that a mixing desk will supply to a microphone that needs it. Condenser microphone. Dynamic mics don't need phantom power, and ribbon mics should never ever receive it. So ideally, if your mixing desk has separate phantom power switches for each channel, that's going to be better. This Cloudlifter here will actually stop phantom power from reaching a ribbon mic or any mic that doesn't want it. If you've got an old microphone that has just a mono jack plug and you put an XLR on it, it's not going to work. And indeed, you should be really careful because you can burn out a phantom power supply really quite easily. Now, phantom power is usually in the modern era, it's 48 volts. You might find older desks that may have 24 volts maybe, but some mics that need phantom power are quite happy with lower voltages. But you've just got to make sure that you read the instruction manual, make sure that you are dealing with the right sort of supply. Now, phantom power should never be applied to anything except a mic, although you can have a DI box that's powered by it, or indeed the Cloudlifter is powered by it. So never connect anything like a guitar up to something using an XLR. Some people do this to boost if you've got a weak line level signal, to put an XLR on it and put it in a mic input. That's okay if it's very weak, but if you do use the phantom power supply on the channel, there might be fireworks. Phasing. What's that? And it's different to the phaser that you'd have on an effects unit. This is more of a problem that you get if you've got your left and right outputs of your mix and it sounds a bit directionless. Indeed, if you have a mono switch on your desk and you press that in, any phase problems that exist in that stereo image will make the level drop ever so suddenly, because you've got maybe +1 here and -1 here. And if you add those together, you get 0. It's never going to be absolutely nothing. But if you press the mono switch in and you get a massive drop in level, chances are you've got a phase problem somewhere. Phasing, you get a phase meter on some big mixing desks in addition to your left and right outputs. And you also, on a digital audio workstation, there'll be a phase meter in the sort of utilities pane of your audio effects, for example. The phase meter runs from -1, which is completely out of phase and undesirable, to +1, which is absolutely in phase, and that's what you want, and there'll be a 0 in the middle somewhere. So when you play your mix back, ideally your phase meter should be bouncing along sort of towards +1. It's never going to be absolutely stuck at 1, because that implies you'd just be playing a sine wave. A mix of lots of different instruments is going to create little phase shifts in itself, but you want that phasing to be as close to +1 as you can. Now, if you do isolate a phase problem, let's say we've got a pair of drum overheads that are working against each other, you can apply a very, very tiny delay to one of those channels, to try and make the phase bounce against +1. Ideally, you would sort this out at the recording stage, so that when you're listening to a drum overhead, you might be turning mics in order that you can circumvent those phasing issues. But be aware that a stereo mix, you can be listening to it without any sort of inkling that there is a problem with phase, unless you press that mono switch in or use the phase meter. It's always worth doing. Phono. This is on a hi-fi amp. This is where you plug your record deck in, phonograph. But it's also a type of connector. You've got phono, or it's known as RCA jack as well. Usually you'll find this on the back of sort of consumer level or semi-pro stuff. I mean, this Fostex R8 behind me has 8 phono ins and 8 phono outs. They are an unbalanced connector, and you've just got to make sure that you buy the best possible phono jack plugs if you do have a bit of this kit, because they're very prone to just working loose. They're not really a connector that you would use in all seriousness, but they are useful because they save a lot of space on a bit of kit. So if you've got a tiny little recorder, chances are it will have RCA phono jacks on it. Any microphone has something called the proximity effect. Now, this happens if you're very, very close to a microphone. You get uncontrollable sort of bass output from it. So you've got to be very careful when you're doing vocals. You've got to sort of balance it out with the room. If you've got quite an echoey room or an echoey space, of course, you need the vocalist as close as possible to the mic to minimize the echo. But then you invite problems with excessive bass end. Now, you can cut the bass on the mic, but you get this thing where it's actually a bit uncontrollable and unpredictable. So you don't want to get too close to a mic at all when you're doing any particularly vocals. But the proximity effect on a microphone is always going to be there, and you've always got to be aware of it. On most multi-track recorders, and indeed some audio interfaces, there is something called punch in or punch out. Now, this is basically a method by using a foot switch that you can set the machine to record and then to stop recording. Say if you've got a solo and you just don't like one particular phrase and you just want to re-record it, you can do it that way. You've also got to be a dab hand at actually bringing that pedal in and playing the solo, so it is a bit of an acquired art, and it's kind of something that's not really done so much these days. On a digital audio workstation, you can actually set punch in and punch out points so that it will do it automatically for you. Now, this can be more accurate because then you're not sort of cutting off a note or actually sort of playing back and then cutting something off the end of your solo as well. So punch in, punch out, it's useful, but it takes a little bit of getting used to, especially for musicians in the modern era who haven't had to use tape recorders. Q is for Q filter. Now, I've already talked about this, but I've obviously got to use the letter Q in my alphabetic glossary. Now, what it is essentially you've got your mid frequencies that you're boosting or cutting, and you can shift usually on a computer anywhere along the audio spectrum, so you can do some quite detailed work. If you have a Q factor that's really high, it means that your band of frequencies that you're boosting or cutting is very narrow. Usually this is because of a problem. It could be that there's maybe a resonance on a tom, or there's a particular note that's a bit sort of honky on a piano that's been mic'd up, for example. Now, you can, to a certain extent, reduce the problem using an equalizer with a high Q factor, but beware of this. Lots of analog mixing desks have a Q factor that's maybe maximum of about 10, but on a computer you can have 100, a Q filter of 100 on Logic's EQ, and it's good, it's useful to have, but there's a reason why mixing desks have a Q factor that's only a maximum of perhaps 10. That's partly the analog circuitry that restricts that, but also, is it musical to actually apply a Q filter that's really high? Well, perhaps not. It really is a corrective measure only. Now, a return is either the input back from an effects loop, so you have send and return on a guitar amp, or the insert on your mixing desk channel. But sometimes if you've sent something to an effects pane, you get a dedicated what's called a stereo return, which means you're not having to eat up your input channels with reverbs and things. So that is a return. Usually you'd have a stereo return on a mixing desk, so that enables your stereo reverb to come back. Sometimes if you plug only one of those things in, the left channel, it sort of switches it to a mono return. So a return is simply bringing something back into a mixing desk that was sent out originally from another channel or an auxiliary perhaps. Reverb. This is basically, more often than not, the only effect that you may have on some mixing desks, or they concentrate on the reverbs more than other effects. Reverb is a really important way of actually connecting with your audience, especially if you're doing live work. It's really nice to have some reverb on your vocals because it just gives you a sense of sort of immediacy. Not only that, it means that the audience is connecting with something that has a little bit of a production value to it. Now, reverb is very, very often overused. I have a general rule of thumb. If I set some reverb on something and listen to it, I just halve the amount. On modern digital audio workstations, you usually have a percentage of reverb. So you have a dry signal, which is your unaffected signal, and you have the wet signal. So if I settle on 15%, for example, I just make it 8% instead. And then when I listen to it, I think, yes, that is an appropriate amount of reverb. It's very, very easy to overdo things. Now, of course, reverb can make things sound much, much bigger. If you've got a drummer who's playing quietly, if you listen to Funky Drummer by Clyde Stubblefield, the James Brown tune, you have a very, very big reverb to make those drums sound really huge. And yes, it's really useful effect. Use it sparingly. Always use it sparingly. And actually, if you are doing a mix, very often it's handy to have maybe only a couple of reverbs on your mix, and you can use sends or aux sends to do that. Having lots and lots of different reverbs on a track can make it sound a little bit disjointed. Depends what you're doing, of course. We use the kit to explore musical possibilities. Signal to noise. You may have seen this in the instruction manual of an older bit of kit perhaps, and usually at the back it'll give you some specifications as to how well that piece of kit will perform. Well, signal to noise is a ratio that's often, well, it's really only expressed in decibels. So for example, the signal to noise ratio of a CD player is 92 dB. That's a standard 16-bit signal to noise. Of course, this doesn't take into account things like the analog converters. When a CD converts back to analog, it's going to introduce some noise along the way, so it may not indeed be 92, but that's the sort of theoretical maximum. On a cassette deck, you might have a signal to noise of 60 dB at best. An old machine like this running at a low speed may have a signal to noise of even lower than that. But it's important that your ears judge if the noise is acceptable or not. Sometimes there's going to be noise on this microphone. There is noise everywhere in every system. So don't give it too much thought. But if you see signal to noise ratio on a piece of kit, it will give you an indication of how good it is at rejecting just general noise and fluffiness and stuff you don't really want. The solo function, you get this on mixing desks, digital audio workstations, and it is simply the mechanism by which you can listen to one track on its own without having to lower the volume of all of the other tracks. So on this little desk here, we've got a button at the top of the channel which actually doubles. Usually you'll find that the solo button also doubles as the PFL switch. Now I've talked about that, the pre-fade listen. And all it does is it cuts the signal from all of the other tracks. Not only can you listen to the track, but you can also see the level that it comes in from the input. So it serves two functions really. Lots of the time, especially on a digital audio workstation, when you've got lots and lots of tracks soloed and you want to unsolo them all to listen to the mix again, it's usually a set of key commands. But on a mixing desk, you've just got to press all the solo buttons in order to release the solo circuit. Speakers. In your studio, you'll have a pair of speakers that have a bass unit, which is the woofer, and then a small one at the top or on the side, depending on how you mount your speakers, which does the treble. You think, oh, where's the mid-range come from? Well, actually, it's dealt with by the woofer. So you've got to be a little bit careful if you're listening at high volume, for example, and there's a lot of bass end, and the woofers are working really hard. The chances are that that mid-range might become unfocused. It's always a good idea to monitor at a quiet volume, because it means that you're listening out for stuff rather than having everything presented at sort of full whack. Now, you can buy replacement speaker drivers for things like Yamaha NS10s. They're only 50 watt speakers, so they're not very powerful. But usually in a big studio, you'll find that driving those NS10s is an amp that's maybe 200 watts per channel. And you think, oh, really? Shouldn't you have the pair of speakers more powerful than the amp? Well, no. Actually not. Perhaps in a PA system, yes, but when you're in a studio, you need an amplifier that can easily control those speakers, can bring the woofers in and out efficiently, and you will find that if you've got a better, a bigger, more powerful amplifier. Indeed, it's very, very easy to blow a pair of speakers with a tiny amp. If you've got a 20 watt hi-fi amp or something that's working really hard, it'll be outputting all sorts of nonsense and square waves and all sorts of stuff which your speakers really won't like. So it's always best in a studio to have an amplifier that is really, really capable. And you will find that those lower power speakers will be really, really happy. Stereo miking. Now, this is really the $64,000 question, and you can do university courses that teach you about acoustics and what stereo miking configurations work where. It's worth reading up about these, and there will be people who are experts, for example, in miking upright pianos or grand pianos. Generally speaking, you wouldn't use a stereo mic configuration on something smaller like the voice, for example, or an acoustic guitar. You've got to be a little bit careful. Now, Bruce Swedian, who did a lot of recording with Michael Jackson in the 70s and 80s, came up with something called the acusonic recording process, where everything was mic'd up in stereo. The idea being that everything would find its own space in the audio spectrum, in the sort of left and right stereo image. But that, obviously, he was an expert at it, and it's very, very easy to introduce phasing problems if you're not careful. Now, something like this, I'm speaking to you at the moment on an AKG C414. They have many different polar pickup patterns. So you've got omni and a cardioid and figure of eight and all of those sort of things. Now, figure of eight is very useful. You can come up with a stereo miking method called the Blumlein pair, which is two figure of eight mics arranged at right angles, and you get a really, really accurate, quite a sort of realistic stereo recording. But you've got to be careful with the room that you're in, because figure of eight means it's picking up stuff equally behind the mic as well as in front. So if you're in a space that's really echoey, you've got to be a little bit careful that you don't get all of that echo where you don't really want it. Now, figure of eight, it rejects stuff to the side, hence the accuracy of that stereo recording. You can also have an XY, which is what most people would do when they're just miking up something. Works best with cardioid pickup patterns where you have the mics arranged at 90 degrees with respect to each other. There are other standards. For example, in France, they have a 110 degree separation for various broadcasts. You have the mid-side method as well, which is really useful because it's always mono compatible. But again, it's really worth reading up on all of these different polar patterns and stereo miking methods. But ultimately, your ears are the ultimate judge. And of course, if you use a phase meter on your digital audio workstation, you can keep an eye on any potential phasing gremlins that might creep in. Stereo. That's what we've had since, the late 1950s on records and then CDs, of course. And most people would expect that a recording will be made in stereo. However, if you go to the Daptone label, for example, you're listening to Sharon Jones or whoever it is, very often they will issue stuff in mono. And it's just because of the sound that they want to get. Now, mixing for mono, that's really hard. And actually, if you have a mixing desk with a mono switch, it's a very good way of checking any phase problems with your stereo recordings as well. Mixing for mono, I've sort of covered this in another chapter. You've just got to be really, really careful that you can hear everything, because you don't have the luxury of placing those things in the audio spectrum. If you are mixing for vinyl, you've got to be very careful that your bass stays in the middle and that you don't have sudden transients on one side, either the left or the right, because actually that's going to cause problems with your cut. But most people, when they're recording in stereo, it's all very subtle and it just gives a nice spatial effect rather than having, drums and bass on one side and something on another side. That's sort of a stereo method that was used by people like the Beatles, for example, but they would have had the awareness of cutting for vinyl, so everything's quite gentle in terms of transients. There's nothing that's really heavy on one side. A sub. Now, this can mean one of two things. Either it can mean a group output or the bus output, for example. Sometimes they're called sub outputs, which is basically just a different way of outputting information from your mixing desk. Or it can be a subwoofer. Now, most of the time when you go and see a band out live, if the PA is good, it will have the top speakers which deal with all the mid and the treble. And then you have massive speakers at the bass, which is for all of the very, very low frequencies. Beware of having a sub in your studio. If you've got a good pair of monitors that have a pretty good bass end, if you have a sub, it can make you sort of rely on it a bit. And actually, when you're mixing bass, if you've got a synth bass that has very little information apart from the very sub frequencies, you can sort of get used to that, and you play it back on another system, you think, I can't hear the bass anymore. This is why I prefer things like the Fender Precision bass guitar, for example, not an active one, because the Fender Precision has a lot of mid-range in, which you will then be able to hear on a smaller system. So beware of having a sub in your studio unless you really know what you're doing, and even then it should be very, very subtle. It should just be able to capture the bass frequencies without going too mad. Swept mid, I've covered this in parametric equalization. It is simply a method by which you can select the frequency that you want to boost or cut. Usually you'd have a fixed bass and a fixed treble control on your mixer, and there'll be a control in the middle which is your mid-range, and you can sweep the frequency that you want to boost or cut. And that's what's meant by swept mid. The Talkback microphone is something that you'll find on many mixing desks. It's simply a button that allows you to communicate with the people the other side of the glass. However, beware of using it in a studio where you've just got one room, because you've got a mic and a pair of monitors, which more often than not will be quite close to each other. So you can end up with a bit of feedback if you're not careful. Talkback mics are really useful because you don't have to use another channel for a microphone, the dedicated microphone to speak to people. And it's also just a button. It's a bit like a CB radio. You press and then you speak, and then when you release, it switches the mic off. On an older mixing desk, or any analog desk, when you've recorded to your 2-track machine, it's going to have to come back somewhere on the mixer. You don't want to use up channels. And indeed, if you bring the machine back on a pair of channels and press record, you'll end up with a feedback loop. So you very often have something called a tape input or 2-track. Now there's an input on here which is CD or tape, and there's actually an output on this mixer, so you send this to your tape machine and it comes back on here, but they are separate, so you can't feed one back into the other. So a 2-track control, you've got to watch out if you don't hear anything on a mixing desk. You've got all your channels open, you can see all the meters bouncing up and down, you think, I can't hear anything. Chances are there might be a 2-track replay or tape return that's pressed in. However, be very careful, make sure you turn down your studio monitor before you then release the tape and 2-track button. I've seen a pair of speakers blown to smithereens with this particular problem. I didn't spot it. The engineer was going, what's happening? I go, oh, pressed a button and the speakers literally decided to disassemble in front of him. No. A track is a physical thing on a recorder. So I've got a hard disk recorder here which has got 16 tracks on it. It's different from channel. There aren't tracks on a mixing desk. A mixing desk has channels. The tracks are reserved simply for physical media itself, and that includes digital audio workstations. Treble can take all sorts of forms. You have presence control on a guitar amp, which is something roughly 4 or 5 kilohertz, and it just gives a presence boost so you can hear it in a mix. Very often a Shure SM58 also has a bit of a lift, so does the C1000. There's lots of mics that have these presence boosts, because otherwise you end up with something that's a little bit too safe, and it can be a little bit hard to hear the sort of detail. Now, usually treble is about 10 kilohertz on a hi-fi amp. On a mixing desk, you can have maybe 12 or even 16 kilohertz that you can boost or cut. Really, that high frequency, 16 kilohertz and upwards, is really the breathiness that you hear in a sound. And you can make something sound very detailed by boosting at those frequencies. But be careful. You don't want something that is really, really tinny. And once again, don't forget your mid-range. Everyone goes on about the bass and the treble, but the mids are very often forgotten. Trim is another word for input gain or the sensitivity of your mixing desk channel. So it's often the first control that you set so that the audio level comes in at the correct level. Sometimes trim is applied to the tape return tracks, because generally speaking, you wouldn't really need to control the inputs. But sometimes you can adjust those if you've got a low recording level, for example, or one track's a little bit deficient in level. You can adjust it usually using the trim control. A VU meter. Now, this is an old school and analog meter, which is simply a needle that moves according to your recording level. They are very useful things to have. If you've got a bar graph that is really sort of responds very quickly to things, it can sometimes give you a sort of false impression of what's actually coming out of your desk or going onto your tape recorder or something like that. Because a needle is a physical thing, it has some inertia, which means it'll smooth off the sort of quick response, which actually might make more of a difference to your level. You can actually sort of work with a tape recorder, for example, or anything that's got a VU meter on it. It's usually tape recorders. But some big mixing desks have VU meters on as well as bar graphs, and it just gives you an impression in sort of two different formats. The XLR plug. This is used to connect all really professional microphones up to mixing desks, and also between audio bits of kit, either at mic level or line level. Now, it has 3 pins and it's all latching, so you plug something in, you've got to press a button in order to withdraw it, and there's a similar little sort of tag on there to allow that to latch. Pin 1 is always the ground pin, and the pins are always labelled. It might be quite faint on the connector, but pin 1 is always the ground wire. Pins 2 and 3 are the signal wires. Remember how I talked about balanced line? You've got one plus signal and one minus one, and they are on pins 2 and 3. Depends where you are. In the US, I think pin 2 was the hot pin or the plus pin, and in Europe it's the other way around, it's pin 3. It doesn't really matter anymore as long as your leads are consistent. If you swap pins 2 and 3 on a cable, and you can do this, for example, if you want to have a cable that has a phase reverse, for example, if you're miking a snare drum from underneath. But usually on a mixing desk, you'll have a phase button that will allow you to swap pins 2 and 3, essentially. And you can use that to correct for all sorts of other problems as well. The XLR is sometimes called a Canon, and it was named after Mr. Cannon, who invented it all the way back in 1950, so there's quite a lot right with it. 3 pins is the norm, but you can get 5, 6, 7 pin XLRs for various other things. For example, if you have a stereo microphone with a single lead, it might come with its own XLR cable. XLRs are also sometimes used to connect amplifiers to speakers, but obviously you've got to be very, very careful that you don't use anything like a mic cable to connect an amp to speakers, because the cable is simply too weak to handle lots and lots of power. Sometimes if you've just got a speaker, it might be that you use just 2 of the pins, pin 1 being the ground and then pin 2 or 3 being the signal wire. If it's pin 2, that would be better because it's further away from pin 1 physically. So there's the XLR cable. And lastly, Z. Z is simply impedance. That means that you see high Z input on the front of your amplifier, for example. That's to connect things like electric guitars. And there endeth the A to Z compendium.